Hello my beautiful students, so welcome back to a new session of KCET Masterstroke. So today we are going to discuss the amines chapter. I guess the previous whatever was covered in chemistry you understood. In case any doubt you are having, please let me know in the comment section, and definitely during the live session when we will solve the PYQ, then come up with your doubts, we will solve with complete interaction. Okay, so yes, without further delay, let's get started with the chapter. So these are the things we are going to cover today. First, structure, classification, nomenclature, preparation, physical properties, chemical properties, diazonium chloride salt preparation, diazonium chloride salt physical properties and chemical properties. Okay, so yeah, this is the structure. As you can see, structure of ammonia. So what happens, it's a tetrahedral geometry, but actually bond angle should be 109.5 degree, but it doesn't happen for ammonia. Why? Because of the lone pair bond pair interaction. So this lone pair and the bond pair, they repel each other. As a result of this, the bond angle reduces from 109.5 to 107 degree. Okay, let's proceed. Classification, you can see amines are classified in primary, secondary and tertiary depending upon the number of hydrogen atom replaced by any alkyl group. Okay, so here you can see this is ammonia, right? One hydrogen is replaced by one R group, this is 1 degree. If 2 hydrogens are replaced by 2 R group, then it is secondary. If 3 hydrogens are replaced by 3 R, then it is tertiary. Next, this is a common nomenclature technique. You can just simply go through it. No need to go to a very depth of it, because not that many question comes out of it. Just remember a little bit. Let's proceed. Okay, before proceeding ahead, let me just tell you, Deeksha already launched the most awaited test series, that is ABHYAS KCET test series. So if you are really preparing and you are really having a proper goal about your upcoming KCET examination, enroll yourself today itself in KCET ABHYAS test series. You will get 35 mock tests where you can judge your capability, where you are actually standing right now, and with these, to get a premium experience, you can also take the KC30 batch as well. Here the expert faculty will provide you the live online crash course, the previous year questions, complete syllabus analysis of PU1 and PU2 chapter wise KCET PYQs, and 10 full length mock test add-ons you will get. Okay, and definitely every day will be a doubt solving session from the expert faculties. So if you really want to get a proper structured schedule further on, then take this KC30 batch, and now it is available in 2499, but after February, after 25th February, the price will not be same. So yes, sooner the more beautiful. So please take it without further delay. So yes, we will discuss about the preparation of amines. So we will discuss the preparation by reduction of nitro groups, ammonolysis of alkyl halide, reduction of nitriles, reduction of amides, Gabriel thalamide and Hoffman bromamide degradation. So one by one the reaction we will learn. So yes, let's proceed. Okay, so here I will try to make a brain map for you. Let's proceed. So we have to make RNH2, right? Okay, so we can start from what was the first thing, that is reduction of nitro compound. Okay, so let's say I am having a nitro compound like RNO2. From RNO2, if I want to come to RNH2, I can simply give H2 in presence of palladium. I can keep ethanol as well. Okay, or I can give SN in presence of HCl, or I can give iron in presence of HCl. So these many options are there from nitro to RNH2. Now let's proceed with the next one. What was the next one? Ammonolysis of alkyl halide. Okay, so let's say I'm having alkyl halide. Let's say I'm having RX type of compound, right? So I have to do the ammonolysis of of this first. So I have to treat it with ammonia. So ammonia will attack here and this X will leave. Okay, as a result of this, I will get the compound something like R NH3 plus X minus. From here to here, just give NaOH, it will come up to be RNH2. Okay, then from nitriles group we can start, that is RCN. Okay, so RCN to RNH2, what I can give H2 in presence of nickel, or I can give lithium aluminium hydride. Okay, so or I can give sodium, amalgam in presence of C2H5OH, okay, in presence of ethanol. Okay, these are the possible options from the nitrile groups. Okay, let's do it from amide. So let's say I'm having RCO NH2. From here to amine, if I want to come back, I can simply give lithium aluminium hydride. Okay, let's do one more. Hofmann bromamide degradation that I can show here. Let's say I'm having again, let's say amide RCO NH2. Okay, if I give NaOH in presence of Br2 in presence of NaOH, that will also give you the amine. So what is this? This is basically Hofmann bromamide degradation, right? One more reaction is there, that is Gabriel phthalimide. So just let's do it. This reaction is important, the mechanism you need to know for this case. So first we will start with the phthalimide. So this is basically, so I am starting with the phthalimide, C double bond O, here C double bond O. Okay, this is your phthalimide. Okay, then treat this thing with KOH. So once you are treating this thing with KOH, it will undergo acid-base reaction. As a result of this, you will get this type of thing. Okay, so first then we will treat this with alkyl halide type of thing, Rx. So here what happens, this N minus will attack over here, right? And this X will be gone. So I will get something like this. Here I will get NR, right? Now here I will give let's say NaOH. Okay, as a result of this, the phthalimide will open up, it will give you CO O minus Na plus, here also CO O minus Na plus. Along with that you will get primary amine RNH2. Okay, you will get primary amine. Okay, that is your Gabriel phthalimide reaction mechanism. Okay, I guess it is clear to you. Let's proceed further. Okay, so here we will discuss about the physical properties, then chemical properties. In chemical properties, you can see basic nature, alkylation, acylation, carbylamine reaction, reaction with nitric acid, reaction with aryl sulfonyl chloride, electrophilic substitution. In that nitration, sulfonation and halogenation we will cover. Okay, let's proceed about the physical property, solubility. So definitely if the aliphatic chain is low, I mean very small, then it is having it is nicely soluble in water because it can form hydrogen bond. The nitrogen can form the hydrogen bond, right, with the water molecule. Okay, let's proceed with the physical properties. First comes solubility. So lower aliphatic amines, they are nicely soluble in water because they can form hydrogen bond with the water molecule, but as the molar mass of the amines increases, hydrophobicity increases and it becomes lesser soluble in water. Now let's come to the boiling point. The order of boiling point is primary, then secondary, then tertiary, the normal boiling point. Okay, but here comes the basicity is a little bit tricky because in gaseous phase and aqueous phase the basicity order is different. Okay, in gaseous phase what happens, the normal thing, that is the tertiary amine is more basic, then secondary, then primary, then NH3. Why? Because tertiary amine has 4 alkyl group that will push the electron towards the nitrogen, and that lone pair will be more available for the donation, hence basicity increases. That is the normal trend. But whenever it comes to aqueous solution, there comes different factors that actually predominates this basicity. Okay, so here what happens, the order of basic strength in case of methyl substituted amines and ethyl substituted amines in aqueous solution are something like 2 degree, then 3 degree, then 1 degree, then ammonia. Okay, this is the general order. Okay, because of the hydrogen bonding and other factor that predominates over here. Okay, now if you just compare aryl amine versus ammonia, then definitely ammonia is more basic than that of aryl amines, because in aryl amines a lone pair of nitrogen is involved in resonance with the benzene ring, right? As a result of this, unavailability of lone pair makes it less basic. Okay, let's proceed. Chemical reaction, we will proceed with the basic nature, alkylation, acylation, carbylamine reaction, reaction with nitric acid, reaction with aryl sulfonyl chloride, and electrophilic substitution reaction, there nitration, sulfonation, halogenation. Okay, so let's proceed with the chemical reaction one by one. So we are going to start from RNH2, right? We are going to start from RNH2. Okay, so let's treat this thing at first with HNO2. Okay, nitrous acid. So if you treat this with HNO2, that will give you diazonium chloride N2 plus Cl minus. So further on being treated with water, you can get phenol out of it. Okay. Fine. Next, let's proceed with carbylamine reaction. Let's say I am having CHCl3 chloroform in presence of KOH. Okay, a little bit heat. Okay, then you will end up with RNC isocyanide, that is of foul smell. Okay, this is your carbylamine reaction. Okay, let's proceed with next one. Let's do some acylation type of reaction. Let me just treat this thing with C6H5 COCl. Okay, acylation type of reaction. So it will form RNHCO C6H5. Okay, let's proceed with some anhydride type of thing. Let's say RCOOCOR. Okay, you will end up with RNHCOR. Okay, let's proceed with, let's say, RCOCl. This is quite similar to that of this, we can avoid this. Let's proceed with RX. Okay, so if you treat this thing with RX, it will give you the alkylation. So this thing is basically your acylation reaction, right? Acylation. Okay, now if you treat it with RX, then you will get RNHR, right? This is your alkylation. Okay, So these are the reaction that you can expect out of the amines. Okay, electrophilic substitution type. Okay, sorry, not electrophilic substitution, but chemical reaction. I just missed the place. Okay, so we have to proceed with the chemical reaction. So yes, here we have to prepare basically RNH2, right? Chemical reaction related to RNH2. Fine. So first, what we will treat? We will treat this thing. We will treat amines with, let's say, HNO2. So if you treat this with HNO2 given 0 to 5 degree Celsius, you will end up with diazonium chloride, right? N2 plus Cl minus. Further, if you just a little bit elaboration, if you give water, you will end up with phenol, right? Okay, so further, if you just treat this thing with, let's say, CHCl3 plus KOH, a little bit heat, that will give you the isocyanide, right? NC, that is of foul smell. Okay, so this is your carbyl amine reaction. Okay, next let's do alkylation. So if you treat this thing with Rx, okay, then it will be R, let's say R prime, RNH, R prime. This is your alkylation. Okay, now let's treat this with, sorry, if you treat this with RCOCl, RCOCl, then this is basically acylation. You will end up with RNHCO, this is, let it be R prime, R prime. This is your acylation reaction. Few more example. You can treat this with anhydride as well. RCOOCOR. Then also you will get this RNHCOR. Okay. One more example. Let me just treat it with C6H5COCl, means benzoyl chloride. Then you will end up with RNHCO, then C6H5. Okay, all these three you can see, these are the type of acylation. Okay, I guess this chemical reactions are a little bit clear to you. Next, let's proceed with the aryl sulfonyl chloride. This is basically the Hindenburg reagent, right? So if I draw this, this will look something like this. S double bond O, like that, Cl. This is Hindenburg reagent, very important thing. Okay, so let's see how actually primary, secondary and tertiary amine, they react with the Hindenburg reagent. Okay, first we will discuss with the primary amine. So let's say I am having N, R, here hydrogen, and here I am showing the sulfonyl chloride, aryl sulfonyl chloride, S double bond O here, double bond O here, Cl. Okay, so here what basically happens, this Cl and this hydrogen, they gets eliminated and you will get this thing. You will end up with this. So these particular compound, what is formed here, it is soluble in alkali. Why it is soluble in alkali? You know, this particular hydrogen is acidic hydrogen, it's still there. Okay, so it can further react with alkali. That's why it forms salt, and that is soluble in alkali. Okay, now again, if I just, this is my primary amine, right? This is 1 degree. If I do it with the 2 degree, let's say I'm having N here, R here, hydrogen here, hydrogen. Right, one R group. So here if I just proceed with the same thing here as well, then I will end up with this type of structure. See, I will get S double bond O, nitrogen. Both the cases, both the hand will be substituted with R group. Okay, there is no acidic hydrogen and hence it is insoluble in alkali. Okay, so whenever you will see that after reacting with Hindenburg reagent, some precipitation you are getting that is insoluble in alkali, you can tell that it is secondary amine. Okay, last if you proceed, N R R R. Here there is no hydrogen, you can see. So that's the reason here no reaction takes place. Okay, so this is how you can separate primary, secondary and tertiary amine using the Hindenburg reagent. I guess it's clear to you. Let's proceed for the electrophilic substitution. So for electrophilic substitution purpose, we can take aniline. Okay, so one by one let's do. So what I can do, let's do bromination. I am giving simple Br2 in presence of water. Okay, so amine group is basically ortho-para directing, so you can get this type of thing. Here Br, here also Br, in the para position also Br, here NH2. Okay, next I can do the nitration, concentrated HNO3 and concentrated H2SO4. So mixed acid I can give out of it. Okay, and I will get all ortho meta para. Okay, so you can see I will get NH2. Here this is your para, definitely that's going to be maximum percentage, 51% I will get, plus I can get ortho substituted nitro as well. This is very less, this is basically 2%, and I can get meta as well. NH2 in the meta position in O2 I will get 47%. Okay, next I can give only H2SO4. I can give only H2SO4, so it will become something like NH3HSO4. Okay, further on being heated, let's say I am giving temperature 453 to 473 Kelvin. If you heat this, you will get this type of compound. Okay. Okay, so the beauty of this compound is it can exist in the Zwitter ionic form. So it can exist in Zwitter ionic form. As you can see here one basic moiety, here one acidic moiety, right? So this can release its acidic hydrogen, okay? And as a result of this, you will get here NH3 plus, and here you will get SO3 minus, okay? So it's a very important part, it exists in Zwitter ionic form, okay? Now let's proceed with one more. Let's give acetic anhydride CH3CO whole twice O, okay, and in the presence of pyridine. So here you will end up with NHCOCH3, right? Just now we discussed this type of reaction. Now if I give bromine here, Br2, okay, Br2 in presence of acetic acid, let's say CH3COOH, then I will get para bromo substituted compound, okay. So this is highly selective, that's the reason I am making it at first NHCOCH3 to block the ortho position. okay, and only in the para position it will be substituted. Now if you just give simple OH minus, okay, if you give simply OH minus or H plus, this entire NHCOCH3 will be converted to normal aniline. Okay, so precisely if you need only para bromo substituted compound, you can block the ortho position like by creating some steric hindrance. Once you will just NHCOCH3, it's a very big group, right? So ortho group will be blocked by default. So then you can do the bromination and then you can just remove the NHCOCO3 group. Okay, so I guess you understood this. Okay, one more thing that we can proceed out of it, you can do the nitration as well from here. Okay, from this. Okay, from here what you can do, if I give H2SO4 and HNO3, that is a mixed acid. Okay, so I can get only para nitro. Okay, so I will get only para nitro product. Now if you give OH minus in presence of or H plus, then this will be converted to NH2 and you will get the nitro group. Okay, normal nitration, you can see you will get ortho meta para, but if you want predominantly para, then you can just proceed with this thing. I guess it is clear to you. Let's proceed further. Okay, one question. When ethylamine is heated with chloroform and alcoholic KOH, a bad odor compound is formed. The compound is definitely isocyanate. Okay, let's proceed. Part 3, that is a preparation, physical properties and chemical properties of diazonium salt. Okay, so first we will do the preparation. What I have to do, I have to take aniline. In aniline, what is the condition? I can give NaNO2 plus HCl. In situ they will produce HNO2, that is nitrous acid. Okay, you can give 0 to 5 degrees Celsius temperature. As a result of this, you will end up with the benzene diazonium chloride formation, N2 plus Cl minus. Okay, along with that NaCl plus H2O byproduct. So this is the preparation of benzene diazonium chloride. Let's proceed. Physical property, this is colorless crystalline solid soluble in water. Okay, chemical reaction, let's proceed. A lot of chemical reaction we can expect out of it. A reaction involving displacement of N2 and coupling reaction. So replacement by Cl minus or Cn minus by I minus, by F minus, by H, by OH, by NO2. Okay, so these many reaction we can proceed, then coupling reaction. So let's do. So let's say I am having diazonium chloride N2 plus, let's say X minus. Okay, okay, so now if I just give, let's say first Cu2Cl2 in presence of HCl. Okay, I will get, I am writing benzene as Ar. So ArCl, this entire thing will be replaced. It is nitrogen replaced. Okay, let's say I am giving Cu2Br2 in presence of HBr. Okay, I will get ArBr. Okay, let's say I am getting CuCN, HCN. Okay, I will end up with ArCN. Okay, all these things are Sandmeyer's reaction. All these are Sandmeyer's reaction. Okay, next what I can do, one more with the reagent we can play. Let's say I am giving CuHCl, only Cu and HCl. Then also I will get ArCl. Let's say I am giving only Cu and HBr. That case also I am getting ArBr. Okay, now let's say I am giving Ki. Okay, I am getting ARI. Okay, now what I can do, I can add fluorine here. I have to treat it with HbF4 at first. HbF4 will give you Ar N2 plus BF4 minus, then a little bit heat you have to give, then ArF plus N2 plus BF3. Okay, so ArF also I got. Now what I can do, I can simply give water to it, it will be converted to phenol. Okay, what more I can do? Okay, I can give H3PO2. I can give H3PO2 in presence of water. That will give you the benzene ring itself. That will give you the benzene ring itself along with that HCl plus H3PO3. Okay, now what I can give, anything left? Yes, one more thing I can give, that is I can give ethanol directly here. I can give ETOH, ethanol. Then also I can get benzene out of it. Okay, I can get benzene as a byproduct. I can get N2 plus HCl, okay, plus CH3CH2. That's it. These are the all probable chemical reaction. Okay, I guess it's clear to you. Let's proceed. Okay, here we will discuss the coupling reaction. Okay, let's go. So I am having, let's say, benzene diazonium chloride, this thing, N2 plus Cl. Okay, let me just break this structure, then it will be easier for you. So I am having this Cl minus. Now I am adding phenol in it. So here I am having one hydrogen. So now this hydrogen and chlorine will be bonded. As a result of this, here you will get N double bond N, and here the entire phenol group. Okay, so this is orange in color. This is orange in color, and you can call it para-hydroxy azobenzene. Okay, next, let's say I am taking another benzene diazonium chloride and I am now coupling this thing with aniline. Same thing will take place. Okay, here what happened? Here I will get something para-amino, right? Para-amino azobenzene. I will get para-amino azobenzene. What is the difference? It is yellow in color. Okay, what is the color of it? This is yellow. What is the name? Para-amino azobenzene. Okay, I guess this is clear. These two coupling reactions are only important. Okay, so I guess it's clear to you. Yeah, let's proceed. One question: the reaction of benzene diazonium chloride with aniline yields yellow colored dye. So definitely just now we did para-amino azobenzene. Okay, yeah, that's it. That's all about the amine chapter. Very small chapter, easy chapter, and precise reaction. Only those probable reactions will come. Don't worry about it. It's fixed in your board examination as well as in the KCET as well. So make sure that you are covering them properly and going through the chapter. Don't skip it. And yes, if you are facing any problem after this chapter, then please comment me below. And yes, if you have not subscribed the channel, do subscribe, and also don't forget to like and share. Thank you for watching the video.